Authentication, Authorization, and Accounting, AAA. Let us explore the core network architecture of AAA, which stands for Authentication, Authorization, and Accounting. In a small network, you might manage users manually. But in a massive organization, you need a centralized system to control who is on the network and what they are doing. AAA is the standard framework used to provide these security services. To master this concept, you must understand each of the three A's as a distinct step in the security lifecycle, as well as the protocols like Radius and TACACS+, that make it work. The first A, authentication. Authentication is the "who are you" step. It is the process of verifying a user's identity before they are allowed to access any network resources. When you connect to a professional network, the AAA server challenges you to prove you are who you claim to be. This is usually done through factors of authentication. This could be something you know, like a password, something you have, like a physical security token or a smart card, or something you are, like a fingerprint or a facial scan. In a modern secure environment, we use multi-factor authentication, or MFA, which requires at least two of these different categories to grant access. This ensures that even if a hacker steals your password, they still cannot access the network without your physical token or your biometric scan. The second A, authorization. Once your identity is verified, you move to the second step, authorization. This is the "what are you allowed to do" step. Just because you are an employee does not mean you should have access to everything. Authorization defines the specific permissions and restrictions for an authenticated user. For example, a junior technician might be authorized to view the network status, but only a senior administrator is authorized to change the configuration of the core routers. The AAA server handles this by sending a set of attributes back to the network device. These attributes tell the device exactly which commands the user can run, which VLANs they can access, and what time of day they are allowed to be logged in. The third A, accounting. The final step is accounting. This is the "what did you actually do" step. Accounting tracks the user's activity while they are connected to the network. It records when the user logged in, when they logged out, which files they accessed, and which commands they typed into a router's console. This creates a vital audit trail. From a cybersecurity and digital forensics perspective, accounting data is priceless. If a network configuration is accidentally deleted or a security breach occurs, the accounting logs allow you to look back in time to see exactly which account was used and what specific actions were taken. It provides the accountability necessary for a secure enterprise. The protocols, Radius and TACACS+. To perform these three functions across a large network, we use two primary protocols to talk to a central AAA server. First is Radius, or Remote Authentication Dial-in User Service. Radius is an open standard that is primarily used for network access, such as connecting to a VPN or a wireless network. It is efficient because it uses the fast, connectionless UDP protocol. However, it only encrypts the password. The rest of the packet travels in clear text. Second is TACACS+, or Terminal Access Controller Access Control System Plus. This is a more advanced protocol often used for managing high-end network hardware like routers and switches. Unlike Radius, TACACS+ uses the reliable TCP protocol and encrypts the entire packet, making it much more secure. It also keeps authentication, authorization, and accounting as completely separate processes, giving administrators much more granular control. By mastering the who, the what, and the record of the AAA framework, you will be prepared to manage secure access for thousands of users across a complex global infrastructure.